Click the bell icon to get latest videos from Ekeeda.
Hello friends, welcome to Ekeeda. Today we will see problem number 5 on Thevenin's and Norton's theorem. So let us see that problem. So you can see here, we have to find the current in this 6 ohm resistor. And there is a voltage Vx which is given with minus and plus polarity. So this is a point to be noted. And there is a voltage source whose value is 2 into Vx. So what this Vx is, what we have to find. You can see we can call this point as some node C, or we can call this as node voltage Vc. And as you know, as we have seen the same procedure for first 4 numericals, we have to follow that procedure. And the procedure is, first is calculation of VTH. That means Thevenin's equivalent voltage, where from this branch where current is to be calculated. So we will open this branch because we have to find VTH. So we will open this branch where VTH or current is to be found. Across this branch where 6 ohm resistance is connected, let's give name as A and B, and we will open this A and B and we'll redraw the circuit. So you can see here, I have opened this branch between A and B, that is 6 ohm resistor. The remaining circuit is as it is. So because this A and B terminals are opened, this is not relevant. So actually our circuit is only this much. So what we can do, we can apply KCL here, because by that we will be able to find Vc. And once we find this Vc, we will be able to calculate what is Vx. So let's apply KCL at this node. So at this particular node, obviously this is incoming current and this is supposed to be outgoing current, like this. So 3 equal to, by KCL, incoming current is equal to outgoing current. So 3 will be equal to outgoing current, means the current which is passing through this resistor. So that will be Vc minus 18, because current is voltage divided by resistance. So it is Vc minus 18, minus because it is from positive to negative, so it will be minus 18. Had it been minus plus, then there would have been plus sign. So Vc minus 18 divided by 1. So simply I will get 3 equal to Vc minus 18, or Vc equal to 18 plus 3, that is 21 volts. So you got this node voltage. Now what we can do, we can apply KVL here for this loop. And when I apply KVL, I have this voltage Vx, which will be required to me, and I can calculate this voltage. So if I apply KVL here, what I will get is 18, then plus Vx, and then minus Vc, because this is plus, there is a grounded node here. So this is plus minus. So it is going to be 18. So let's apply KVL. There is no point in calling it loop 1 because there is only one loop. This is not a loop. So by applying KVL to this loop, what we get is 18 minus, it is minus to positive, so it will be plus. So 18 plus Vx minus Vc equal to 0. And then Vc value is 21. So we can write Vx is equal to 18 minus 21 will be minus 3. And that will go here, it will become plus 3. So Vx will be equal to 3 volts. So the first conclusion that we have got is Vx equal to 3 volts. Now why it is required? Because this particular voltage source has 2 into Vx value. So if I want to find the VTH, so for that we'll take imaginary voltage source. So which we have been doing. So we'll put imaginary voltage source here between A and B. So this is called VTH. Now we can again apply KVL here. So now if we apply KVL to this entire loop, because this is a condition of super mesh, so even if we apply KVL to this entire loop, what we'll get is 18 plus Vx plus 2Vx minus Vth equal to 0. So let's apply it. I am considering this entire loop, all these outer nodes. So let's apply KVL here. So by KVL to super mesh, that is the equation which we are getting. As we want Vth, we'll take it at one side. And already we have the value of Vx. And that Vx value is 3 volts. So it is going to be 3 into 3, that is 9. So 18 plus 9, it is going to be 27. So the step number 1 is done. That means Vth is equal to 27 volts. Now let's move forward. After Vth, second step is calculation of ISC. That means short circuit current through the given branch. And as we know that for calculation of ISC, that means short circuit current, we have to short that particular branch. So again, we'll redraw the circuit. So the same circuit where this branch is shorted. So here we have drawn the circuit and we have to find I short circuit, that means short circuit current. So we can give names to these currents. So let's call this current as I1 and let's call this one as I2. The reason is then we will have this super mesh condition and we can write that I2 minus I1 equal to 3 amperes. So this is one equation we have. And then this I short circuit, you can see if I apply KCL at this particular node, I short circuit is outgoing current, this 3 ampere is incoming current, and you can see that the I1 is also incoming current. So let's apply KCL. I1 incoming plus this 3 amperes is equal to I short circuit. That means it is equal to I2. We can call that I short circuit equal to I2. Now we have to find I short circuit, but we don't know what is I1. Very easily you can see I1 is current passing through this resistor, but see the terminal, it is passing from negative to positive terminal. So this current I1 will be voltage divided by resistance with minus sign, because it is entering from negative terminal, so it is going to be minus of Vx divided by 1. So we can substitute this value here, that current I1 is minus of Vx divided by 1, but we don't know what is Vx. We have calculated Vx, but that is for Vth. This we are doing by Norton's theorem or ISC. So we have to find Vx first. So for that also, again we can apply KVL to this entire super mesh and we can get value of Vx. So let's again apply the KVL. So here you can see, if you can apply super mesh, then 18 plus Vx, because it's minus plus, then this will be opened. We consider this as open because we don't consider this particular branch. And then again plus 2 into Vx, that's it, will be equal to 0. So let's write the equation. So we just got Vx equal to minus of 6 volts. And now let's substitute this value of Vx in the KCL equation. I will show you that equation. Here you can see I1 plus 3 equal to ISC, and I1 is minus of Vx plus 1. So let's substitute the value of Vx here. So here I will substitute I1 equal to minus of Vx, but already Vx is minus 6, so it is going to be plus 6. So 6 plus 3, that means it is going to be 9 amperes. So we are done with step number 2 also. Now we know that step number 3 is calculation of RTH. And RTH is VTH upon ISC. So let's check out the values. You can see here VTH is 27 volts and ISC we just now got 9 amperes. So it's going to be 3 ohms. So RTH also we have got. Now the last step is we'll draw the equivalent circuit and we'll get the value of current which is passing through 6 ohm resistor. So let's move for step number 4. So here this is going to be VTH, this is our RTH, and this is the current I which is passing through this 6 ohm resistor. And the RTH value just now we got equal to 3 ohm. VTH value also we just wrote, and the VTH value is 27 volts. So this I, that means current which is passing through this 6 ohm resistance, will be voltage divided by total resistance. Voltage is 27, total resistance is 9, so it is going to be 3 amperes. So that was the question, that we were supposed to find the current which was passing through this 6 ohm resistor, and the answer we got as 3 amperes. That is the end of this problem. So thank you very much guys for watching this video. Stay tuned to Ekeeda and please subscribe to Ekeeda. Thank you.